Thank you for joining me today. I'm going to be talking to you about ordering rational numbers. And before we get started into some examples, let's take a look at some terms that you're going to need to be familiar with as we move through the lesson. First of all, rational numbers. What is a rational number? Well, it's simply any number, negative or positive, that can be written in fraction form. That's the key to this whole term. The term itself, ratio, in the word rational, ratio again is a fraction. So here's some examples of just some numbers that you can use or that you will see that you will need to identify as rational numbers. You can see that any fraction, negative or positive, any terminating decimal, which means a decimal that can end or that will end, or any repeating decimal. There are also some other numbers that fall into this category that you will learn on down the line. So you can see that each of these values that I've underlined here can all be written in fraction form. That's what's going to make them rational. You also need to be familiar with your inequality signs. You can see here we have a less than and greater than. Okay, these are called inequality signs because they show and they allow you to compare numbers based on how large or how small they are. Let's take a look at a few examples here of what you're going to need to do. The first examples we'll look at here are comparing them. We're just simply trying to use these inequality signs to show which number is larger, which number is smaller. In some cases, you may run into an instance where the numbers are actually equal, so you need to be aware of that. Let's take a look really quick here at -3 and -8. And the first strategy you may want to implement here is using a number line. Okay, a number line is a nice basic way to organize your thoughts when you're dealing with negative and positive numbers. We know that 0 separates your positive numbers from your negative numbers, so I'm going to put 0 on the number line there. We're looking at -3 and -8, so you need to think, where is -3 going to fall? Well, we have -1, -2, then -3. -3 is going to fall right here on our number line, and as we continue, we're going to see that -4, -5, all right, and I'll extend my line here, -6, that's -5, -6, -7, and then finally out here -8. Okay, so I want to show you here, mark that with red, that we have -3 and we have -8. So when you're dealing with rational numbers and comparing them, what you're actually trying to do, especially with negative numbers, is determine which number is closest to 0. That means it's actually larger. When you're dealing with negative numbers, it's the opposite thought process. On the positive side, of course, 8 is going to be larger than 3. We know that. On the negative side, it's the exact opposite. So in this case, -3 is going to be greater than -8. Okay, -3 is closer to 0, which makes it larger. Let's take a look at the next example. All right, on the next example, we're dealing with two fractions. Now, with fractions, it may be a little bit more difficult for you to see which one's larger because you may not be comfortable with fractions and their particular sizes based on just looking at the number. Well, we have a backup plan, and that backup plan is fractions, changing those fractions to decimals. So we're going to change these fractions to decimals in order to see which ones are larger. We're more familiar with decimals probably because of using money, because our monetary system here, we use decimals quite often. So it's really like comparing change. So in -1/2, to change -1/2 to a decimal, we're going to divide 2, the denominator, into the numerator. All right, 2 does not go into 1, so we need to include a decimal and another place value. We're going to move our decimal straight up, and now we can divide 2 into 10. When we divide 2 into 10, it goes in evenly 5 times. So we see that -1/2 is going to become -0.5 or 0.50 if you'd want to write it like that. The 0 is not necessary. So let me go back up here and we'll do the same thing now with -2/3. We're going to take the 3 and divide it into the 2. Well, again, 3 cannot go into 2, so we have to add a place value and move our decimal directly straight up. 3 goes into 20 now. That's going to be 6 times. 6 times 3 is 18. Go ahead and subtract there. You see you get 2. 20 minus 18 is 2. We can include one more place value, bring down that 0, and you'll see that we actually are going to get another 6. this is actually what we call a repeating decimal. So we can stop there. We'd usually put the bar over it to show that it repeats. And so we're actually going to be comparing negative 0.5 to negative 0.6 repeating, okay? Now this can be a little tricky because, again, if these were positive numbers, that's going to be pretty simple. The 6 is always going to be greater than the 5. However, since they're negative, that means it's going to be the exact opposite. So again, if you get confused, you can draw out your number line if need be and find out where they would land on the number line. In this case, negative 0.5 is actually going to be greater than negative 0.6 repeating. All right. A couple more examples here. We're looking at two decimals, negative 16.8 and negative 16.5. So again, we're dealing with a lot more negatives here to try to get you more comfortable with how that works. Negative 16.8, since it's already in decimal form, we can, with both of these numbers, we can just look at them and determine based on what I've told you before, which one is larger. So again, I realize that negative 16.8 looks larger than negative 16.5, but when you're thinking like that, you're thinking of positives. You have to think on the opposite end of the number line. So again, just to show you on a number line what this would look like. If you had negative 16 here, all right, you would have negative 16.5 and then negative 16.8. When you're counting, it would go 16, negative 16.1, 2, 3, 4, 5, 6, 7, 8. Okay, so though it looks larger, again, you got to think opposites because it's the other side of the number line. So with this problem, negative 16.8 is actually going to be less than negative 16.5. All right, then the bottom example. This example on the bottom can be a little confusing because, again, sometimes when we see numbers with more digits, we automatically will think that they're larger, or in this case, it's actually smaller, but we'll get to that in a moment. Negative 2.05, we're going to compare that to negative 2.5. And what I want you to do is include a 0, okay? You want to include a 0 on negative 2.5 so that you can take both decimals out to the same amount of place values. That allows you to compare them as normal numbers. So for instance, it's like comparing 205 to 250, okay? So we understand that a little bit better. Otherwise, it looked like 25 and 205, which is not exactly accurate here. Now, because they're both negatives, again, I realize that it looks as though negative, or that 250 would be larger than 205. And that would be the case if these were positives. However, they're negatives. So again, we have to keep that in mind when we write our answer. So in this case, negative 2.5 is actually going to be less than negative 2.05. All right. And one little trick to remember if you get confused with these inequality signs is remember that the less than sign, you can make an L with your left hand like we used to do with left and right. Well, that's also your less than sign. So you can keep that in mind, just a little trick to remember if you get those confused, because they are easy to confuse. So this one looks like an L. If you would stand it up right, that's less than. All right, the next example here, we're going to actually order them. We get a group of them together and we're going to place them in order. Again, if you have a number line handy, this is a great way to organize your thoughts. But because we have a mixture of fractions and decimals, what I would like you to do, and what I'm going to show you how to do, is make them all decimals because we're a lot more familiar with that. So the first thing we're going to do is modify negative 3 1/4 to a decimal. And really all we need to do is take 1/4 because that's the actual fraction or decimal part of this number. So we're going to take 1/4 and we're going to make that a decimal. And by doing that, or to do that, we need to divide 4 into 1, just like I showed you before. So 4 goes into 1, can't, we add the 0. We're going to move our decimal straight up. 4 goes into 10 2 times, which then multiplying gives us 8. We get a remainder of 2. If we bring down an extra 0 here to continue our division, you see that you end up with 0.25. Okay, and that's going to go in evenly. So we end up with 0.25. So when we rewrite the number, it's going to be negative 3.25. Negative 4.1 is already a decimal. Negative 2.85 is already a decimal. All right, and then finally negative 4 2/3. Let's go ahead and modify that one real quick. So we have negative 4 2/3. Again, all we need to worry about is the 2/3 portion. We're going to divide 3 into 2. All right, and again, because 3 can't go into 2, you can see that I'm adding that decimal, moving my decimal directly straight up. And 3 goes into 20 6 times. All right, and that gives us 18 after we multiply. We subtract, bring down another 0. 3 goes into 20. You can see it's going to go in 6 times, and we're going to have repetition. So just as we saw before, this is actually going to repeat. So our last decimal is negative 4.6 repeating. Okay, so as we look at all these numbers, again, you got to keep in mind that the smaller the number on the negative side, the actually how the larger it will be. Okay, so again, negatives work as opposites when you're on the other side of the number line. So if we look at these, you need to be thinking to yourself, first of all, are they all out to the same decimal place? The answer to that would be no. We can see that negative 4.1 only goes out to the 10th place, and 2 other numbers here go out to the hundredths. So we need to take that out one more place. So I'm going to rewrite these. Negative 3.25, negative 4.10, negative 2.85, and then we can easily modify, and again, to take something out another place value, you just typically will add a 0, but for negative 4.6, we're actually going to add another 6 because it's repeating. So now what we need to do is look at these and determine, because we're ordering from least to greatest, and you really need to pay attention to that in the directions because they can flip that from time to time. Your teacher may flip it, okay? We need to figure out which one's the lowest one. So again, because we're dealing with negatives here, we're actually going to look for the higher number. So it looks as though negative 466 or negative 4.66 would be our lowest value here. All right. And then that will be followed by negative 4.10, which would then be followed by negative 3.25, and then finally negative 2.85. Now, depending on what your teacher's asking you to do, you may need to go back and order the original values up here, okay? So that's a possibility. That's really just all dependent on what your teacher wants you to do. But a lot of times they will want you to go back and remodify the numbers down here at the bottom and put them back in their original form. Let's take a look at the next one then. We have one more just like that. We're going to use the same strategy here. We're going to look at modifying our fractions first. We need to make those decimals. So we have negative 1.6, negative 1.6 repeating. Don't necessarily need that many 6's. You can just write 1 if you'd like. We're going to go ahead and make it negative 1.5. Well, 1/2 from the last slide we know actually becomes 0.5, but again, if you've forgotten, that's going to be 2 into 1.0. So 2 goes into 10 5 times, and you can see you're going to end up with 0.5. So that means this number is going to be negative 1.5. And then negative 1 7/9 we have not done, so let's take a look at that one real quick. We're going to actually divide 9 into 7. Again, we just have to worry about the fraction part. Don't worry about the whole number part right now. So we're going to divide 9 into 7. Got to add a decimal and a 0. We're actually dividing 9 into 70. That's going to go, let's see, that's going to go 7 times. Move your decimal straight up. And that's going to give you 63. Subtracting, you're going to get another 7. Okay, if you need to bring down a 0, you can. If you don't notice yet that that's actually going to be a repeating decimal, bring down a 0 and you'll see that it actually becomes a repeating decimal. So you get 0.7 repeating. So let's go ahead and write that out. That's going to be negative 1.7 repeating. Now the good news here is that they're all out to the same decimal place. I know I changed a few of them. Those repeating decimals you really only need one of. So we have negative 1.6, negative 1.6 repeating, negative 1.5, and negative 1.7. This time we're also writing them from least to greatest. So let's go ahead and see which one looks like the largest value. In this case, it looks like negative 1.7 repeating is 1.7. You would typically think of larger than all the rest of these. However, again, because we're on the negative side, that's going to be your first choice. That's your lowest value, negative 1.7 repeating. All right, so now we need to compare negative 1.6 to negative 1.6 repeating. So off to the side, I'm just going to show you really quick. If you have 1.6 versus 1.6. Now again, remember that this one has more 6's at the end. So you're actually comparing 1.6 to 1.666. So in actuality, negative 1.6 repeating is a larger value. So in this case, it's going to go next, or 1.6 repeating would be a larger value. So that's going to be our next one. Then of course 1.6 will follow. Rid of this, and then finally our negative 1.5. And these can get a little tricky, I do realize that, because it's the opposite mindset or the way of thinking that you're used to, because in dealing with negative numbers, again, everything changes, everything goes to the opposite. So another strategy you could use is you could always write them out from least to greatest as positives and know that your answer would then just be the complete opposite of that. That's just something that you can try if you find that you're still struggling with this. All right, let's just take a look and see how they're going to do these with word problems. This one is dealing with a car race and how the cars finish. They want you to write it from fastest to slowest. So again, we're taking these times that these cars get and we're writing them from basically fastest to slowest, which means lowest to highest. So we're looking at 12.23. We're looking at 12.203. And then finally 12.232. Okay. Now you'll notice not all of these are out to the same place value. 12.23 we'll need to make 12.230. And that'll help us compare them all as though they were just typical whole numbers really, but we know that they're decimals actually. But it's like comparing 12,230 to 12,203 to 12,232. So we're going to order these from least to greatest. All right, so which of those looks like the smallest value? Well, that's going to be 12.203 because 203 is less than 230. So our first one there will be 12.203. That's place number 1. Then it'll be 12.230 because 30 is less than 32. And then finally 12.232. And we get those all placed out in the correct order. So that's exactly what they would want you to do. And then the last one. Some students just comparing feet size, okay? So let's go ahead and write out the values they give us. They want you to order it from smallest to largest, so basically least to greatest again. So we have 6.32, 6.333, and 6.032. So again, what you need to pay attention to is that they're not all out to the same place value. It could look like 6.32 is the lowest one, but in actuality, you'll see in a moment, it's not. So take your 6.32 out to the same decimal place, which is the thousandths place, as the other two numbers. And then finally, 6.032. All right, so you can see we have all our values lined up. Now we need to place them from least to greatest. So is 6.032 the lowest? It appears to be so. 6.032, it is lower because, again, if you look at the tens place, it's a 0, where the other two are 3s. That automatically makes that a lower number. The next one will be 6.5 If we're comparing 320 to 333, 320 to 333, of course 320 is going to be less, so 6.320. And then finally, to finish off our answer here, the largest one, 6.333. All right, and this has been a quick tutorial on ordering rational numbers. Thank you for joining me.